Alright, so this is what it looks like in the book. It wouldn't matter. We could have done it the other way, but I want it to be exactly the way it is in your book. And so they said, hey, this is R, this is S. This is clearly the transversal, but they give us some angles, right? They said this is angle 1, this is angle 3, and this is angle 2. And then they said, hey, look, suppose that angle 1
Wait, which one's 3?
is congruent to angle 2. Angle 3?
No, which side is it? Like,
It's the close. It's right here.
oh, okay.
Right here. All right, and it says the fence gate is at the right is made up of pieces of wood arranged in various directions. Suppose angle 1 and angle 2 are congruent. R lines R and S parallel. Now this one we just got to talk about. Well, it says that angle 1 and angle 2 are congruent. What did we call those angles? Yes.
Alternate exterior.
So yeah, so if they're alternate exterior angles and they're congruent, we know that it should be parallel. But we're in this section, we've been proving this using the corresponding angles theorem. So what we would say is that angle 1 is congruent to angle 3. Why? Because they're
equal.
corresponding.
Yeah, is it congruent or equal?
It's both.
For the...
Well, we got to figure it out. Well, we don't. You know what?
She's saying over there you say angle 1 equals angle 2, not
Yeah, it should be angle 1 is congruent to angle 2, right? And then angle 2 is congruent to angle 3. Why? Because they are... No, because they're vertical angles, right? Angle 2 is a vertical angle to angle 2 and angle 3 are vertical angles, right?
right here. Right here.
Yeah, is that congruent?
Well, the textbook says that it's equal or congruent.
Yeah.
So what is the difference between congruent and equal?
Is that congruent when it's like...
Congruency has to do with the angles and the measure of the angles. There's two separate things, right? When we say something's equal, we're just saying that the numerical values are equal, right? For angles, it doesn't really make that much of a difference. On triangles, it makes a huge difference. I can have a triangle that has the same angles but different side lengths. So I could say that the triangles have all of their angles equal, but their side lengths may not be equal. Therefore, they're not congruent triangles. Congruency means they're the same, but it's with regards to the angle and the numerical value. When we're doing these angles, it's not as big of a deal to distinguish between equals or congruent. But since we are doing congruency equivalencies for our proofs, we should probably label them as congruent. Does that make sense to you guys? Okay, so they are congruent, and these are congruent because they're vertical angles. So what does that tell you? Well, that tells you what? Yep. Angle 1 is congruent to angle 3, right? And so that means that, and they happen to be corresponding angles. And so what does that prove? R is parallel to S. Now I wrote this flow proof kind of identical to the way that we would do our T-chart. But I can put those squares anywhere I want, right? I can put those rectangles, move them around the screen wherever I want. The reason we call it a flow proof is because we're saying, okay, we start with this. Is this true? Yep, it's true. Is this true? Yep, it's true. Is this true? Yep, it's true. Therefore, this is true, right? The law of detachment.
And the the reason you can prove they're parallel is because that angle 1 and angle 3 are corresponding and angle 3 corresponding.
Yeah, so because they're congruent, that is the corresponding angle theorem. And so we're basically, if we can find two angles that are corresponding, in other words, if the label corresponding angles, it just means the position of where they are, right? Angle 1 and angle 2 are corresponding. But the theorem is, if the corresponding angles are congruent, then the lines associated with those angles are parallel, right?
So what if you, like, does that work with like vertical angles too? Or does it have to be corresponding?
Well, in this section, we're just using this corresponding angle theorem, which is like the converse of the interior angle theorem. Right. Okay, so the question is, Mr. Adams, I think, what are you doing, right? And what we're doing is basically, on all three of these examples, right, let's go back to example number 1. To prove that A was parallel to B, I needed to prove that the corresponding angles were congruent. So what they did here is they said, hey, angle 1 and angle 2 are congruent. Which lines are parallel? Well, that was easy. I just need to figure out which lines made 1 and 2 corresponding angles. Because if the corresponding angles are congruent, then the lines associated with those corresponding angles are parallel. Right? Does that make sense? So then in example number 2, basically our goal is, if the corresponding angles are congruent, then the lines associated with those corresponding angles are parallel. So they gave us that angles 4 and 6 are congruent. Well, 4 and 6 are not corresponding angles. I had to prove that the corresponding angles in this particular diagram were congruent. If they are congruent, then the lines associated with them are parallel. So I said that 4 and 6 are congruent. That's given to me. I happen to know that 4 and 2 are congruent because of the vertical angle theorem. Hey, I've just proven through transitive property that angle 2 is congruent to angle 6, because both angle 2 and angle 6 are equal to angle 4. Therefore, they're equal to each other.
So angle 2 and angle 6 are corresponding?
Yeah, and so angle 2 and angle 6 are corresponding angles, and they're congruent. Therefore, the lines associated with them, L and M, are parallel. And then example number 3, it's the same thing, right? Suppose that angle 1 and angle 2, which are not corresponding, they're alternate exterior angles, but it says suppose they are congruent. Prove that R and S are parallel. Well, I have to prove that the corresponding angles are congruent. Same thing. Angle 1 and angle 2 are congruent. Angle 2 and angle 3 are congruent because they're vertical angles. Therefore, angle 1 and angle 3 are congruent because of the transitive property. Actually, I probably should put that in there too. This is because of the transitive property. We're substituting in 3 for 2, right? So we have a 2 here, and we have a 3 here, and we substitute the 3 in for the 2. So that's using the transitive property. Okay. So now that I've proven that the corresponding angles are congruent, what do I know about the corresponding lines? They're parallel. So guess what example number 4 is going to have us do?